Hello everyone, so welcome back to YouTube channel and today's question is middle of a linked list. So let's just understand the question first. So we just given the head of a singly linked list and we have to return the middle node, and in case there are two middle nodes we have to return the second. As we can see in the example, there's only one middle node, so we'll return this. Else in case they in this example we are basically 3 and 4 are middle, so we have to return the second one. Okay, so let's just move to the intuition part. So we'll build our intuition from here. So we are given a linked list, like this is the linked list with the odd length and the below one is the even length. Okay, so in this the three will be our middle, and in this, since middle will be somewhere between, so these will be between, since two from here and two from here, and since there are two middles we have to return the second one. Okay, so the first approach we can use is we can find our middle using the length. So the length in this first linked list will be 1 2 3 4 5. So length will be 5, and we have to return the third one, so it will be 5 by 2 plus 1 integer division. Okay, so one approach can be, so mid node will be n by 2 integer division plus 1, and similar in this case the length is 6, so 6 by 2 is 3 plus 1 fourth, so we will return our fourth. So this will be one approach. And in this case, so first we have to find the length of a linked list, and after that we have to find the middle node. So let's just have a like small pseudocode for that. So what we'll do, we'll just have one counter variable, okay, to initialize it to 0, and we will take some temporary variable and initialize it to head. Then we will just go over the linked list like temp not null basically, and increase our count and temp to temp next basically. Okay, and this will basically find our length. Okay, and after that what we'll do, we will mid element will be count by 2. We can just do that in code respectively. Okay, and we'll just count plus 1. Okay, and again we will go over the linked list, reinitialize temp to head and go over the linked list not equals to null basically, and we will just decrease our mid element and check if mid element equals to 0, we will like return our temp. So this will be a small pseudocode, you can just take a small understanding. So in this case the time complexity will be big of n plus big of n by 2. This big of n will be finding the length of a linked list, and this big of n by 2 will be finding the middle node, and space complexity will be big of 1. Okay, so since the time complexity in this will be on plus 1 by 2, so we have to optimize it so to somewhere only big of n by 2. So for that there is one another method, that is tortoise and hare algorithm. Okay, so tortoise and hare algorithm we have like done in multiple questions previously in the linked list, and also some of you might be aware. So in this we use two pointers, slow and fast. Slow as it means it will be taking one step, and fast, as it means it will be taking two steps. Okay, so let's just have a small dry run over our question. So the linked list will be 1, 2, 3, 4, 5. Okay, and now let's just place our small and fast here, or slow and fast here, and slow will be moving by one step. So in the first iteration, slow will be here and fast will be here. After that, slow will be here and fast will be here. So once slow reaches the end of a linked list, we will return our slow, stating that it will be at the middle. Okay, let's just also take an example of a linked list with an even length. Okay, now slow and fast will be here only. So in the first iteration, slow will be here and fast will be here. After that, slow will be here and fast will be here. After that, slow will be here and fast will be at this point, null. Okay. So whenever fast reaches the end of a linked list or it will reach the null, we will return a slow stating that it will be at the middle of a linked list. This is happening because the fast is starting from the odd position. So in case of odd length linked list, it will be at the end, and in case of even length linked list, it will be at the next of an end, that is null. So we will check both for that. So the small pseudocode in this will be like slow to initialize it to head, same fast initialize it to head, and check in a loop while fast is not equals to null, and fast next is not equals to null. So if both conditions are there, we will just move slow by one step and fast by two steps. Okay, so in this, the time complexity, let's just change the color. Time complexity will be big of n by 2, since we are just iterating the half of the linked list, and space complexity will be big of 1 only. Okay, so the reason behind this approach for the slow reaching the middle in case of this, so it's like obvious, because if we can see, if like let's just say like a is traveling with a x speed, and so in the x speed he's covering a distance d. So if b is moving with the speed x by 2, so how much distance will he cover? Will not cover d by 2, right? So yeah, so this is our fast and this is our slow. When fast reaches the end, so slow will be at the middle only. So yeah, that's the intuition behind this approach. Okay, so let's just move to the coding part and do it. Okay, yeah, so let's just have a write the code. So we'll take our pointer, slow to head and fast to head also, and move we will check if fast is not equals to null, if fast is not at the end, and fast is not fast next last node is not equal to null. Okay, so we will move slow by one step and fast by 2 steps. Okay, now once it comes out of loop, we will return a slow, stating that it will be at the middle. Yeah, let's just have a dry run over the example test cases. Yeah, it is working fine. Let's just submit it. Yeah, it is working fine. Yeah, so thanks everyone watching. In case you do like this video, please do subscribe our channel for more videos and latest updates. In case you have any other approach, please do share that in the comment. Yeah, thanks everyone for watching.